Welcome to AmeenAcademy.com. In complex analysis, let us discuss about an overview of complex numbers. Here, here we discuss properties of moduli. Properties of moduli of complex number. Here, z into z bar equal modulus of z the square. Here, that is a complex number into conjugate of this complex number equal to modulus square. Now let z equal a plus bi. Then we can say conjugate of a plus bi is a minus bi. Z into z bar equal a plus bi into a minus bi, which is equal a square plus b square, which is nothing but modulus of z the square, because modulus of z is square root of a square plus b square, but a square plus b square is modulus z the square. The modulus of a complex number and that of its conjugate are equal. That means here z modulus of z is modulus of z bar. That means here let z equal a plus bi, then modulus of z is nothing but a square plus b square. Now conjugate of z is a minus bi, then modulus of that conjugate is same a square minus b square, which is equal a square plus b square. Therefore, you can say modulus of z is modulus of z bar. Then modulus of minus z is lesser or equal to real part of modulus z is further lesser than modulus of z. So we can prove this by using take z equal to a plus bi and find the modulus of that negative. Then we can show that is lesser or equal to real part of the z and lesser or equal to modulus z. Then next property, z power minus 1 is conjugate z over modulus z the square. Now we know that we have here z into z bar is modulus z square dividing by modulus z square. We have z bar over modulus z square equal modulus z square over modulus z square, which is equal to 1. Therefore, z bar by modulus z square equal to 1. Further dividing by z we get z by z bar by z equal modulus z square equal 1 over z. Now this z and z cut, so we have modulus z over z square equal 1 over z is equal z power minus 1. So we proved here. Then next one, fifth. Here the modulus of the product of two complex number is equal to the product of their moduli. That is z1 z2 is equal z1 modulus into z2 modulus. So we can keep z1 is a plus bi, z2 is c plus di. Then we can find the product of them and multiply and find the modulus, which is equal to modulus of z1 and into modulus of z2 we can prove easily. In general, we can say modulus of z1, z2, z3 like more times is equal to separate modulus z2, z3 like product. Similarly can so division also, modulus of z1 by z2 is equal to modulus of z1 over modulus of z2. This also for multiple of z1, z2, z3, z4, z5 you can do that also. Next, here z1 modulus of z1 plus z2 is lesser or equal to modulus of z1 plus modulus of z2. It's called a triangle inequality. Now we'll prove this. Here we'll do proof. Now take z1 plus z2 the square equal z1 plus z2 and z1 plus z2 also you can write, because product of modulus and its conjugate is equal to modulus of that complex number here, which is equal further z1 plus z2 into modulus z1 plus modulus z2. Instead of modulus of conjugate of z1 plus z2 is conjugate of z plus conjugate of z1 z2. Then further multiply z1 modulus z1 plus z2 conjugate z2 plus z1 z2 conjugate plus z2 z1 conjugate, which is equal z1 conjugate z1 is z1 square modulus of z1 square, and here modulus of z2 square plus z1 z2 modulus conjugate plus Z1, Z2, this full modulus. Now further equal here Z1 square plus Z2 square modulus of square equal here, since we know that Z1 Z and Z bar is 2 times the real part, so we can write this is 2 times the real part of Z1 Z2 bar. So then we can say Z1 square plus Z2 square is lesser or equal here. I can say this one Z1 plus Z2 modulus square equal plus 2 times Z1 Z2 bar. Since A is lesser or equal to square root of A square plus B square, therefore the real part of the complex number A plus BI can never exceed its absolute value. After that, from this one we proved first, and now taking positive square root, of both sides, you will get Z1 plus Z2 is lesser or equal to Z1 plus Z2. So this next one, similarly we can say modulus of Z1 minus modulus of Z2 is greater or equal to modulus of Z1 minus modulus of Z2. So this also can prove. We have done. Please subscribe our YouTube channel.